Hello, all. Hello, everyone. A very warm welcome to all the viewers, to all of you joining today in our webinar, which is on Design, Integrate, and Build Your Robot for Codeavour 7.0 International. Hello, all. Hello, everyone. I believe that you all are doing well and excited for this session. Yes, so my name is Karishma and I'll be the host for today's webinar. And before we begin, I request all the participants to kindly drop your name and your country name in the chat box so we know where you are joining from today. And even though I can see many names, many messages in the chat box, that means you all are very excited and joined the live before we actually started. Hello, Sanvi. Thank you for joining. Yes, we are also very excited for this. Okay, so there is a participant with us from Egypt, Westview International Language School. Thank you so much for joining. Hi, Sasha. Hi, Himayat. Thank you so much, guys. Thank you, viewers, for joining. Trust me, this session is going to be really exciting, and this will be really helpful for all of you. And honestly, we are thrilled to have a global audience with us. So, yeah, so let's not wait further. Before we move ahead, I'll give you the brief overview of today's session that what this webinar is basically focused on. So, we are going to talk about 3D printing from concept to reality, advanced robot mechanism, official skill certification. Okay, and to make this session even more impactful, we are proud to have FRC Team Kaizen with us today. So yes, viewers, we have a Team Kaizen with us for this session who is going to share their valuable thought or research with us. But before we start with them or before they start sharing their ideas with us, I have one information or announcement to make here that I'll be sharing one link with you all in the chat box. That is the registration link. And I'm sure that like many of you might have registered already before and some are there who still needs to register. So I request you all to kindly register with us for these webinars so that at the end you can get your participation certificate for this webinar. So I'll be sharing up this link soon in the chat box. Yes. So let's come back to the session, to this webinar. Let's not wait further. And I welcome Darsh from Team Kaizen. Over to you, Darsh. Kindly share your valuable thought and insights with us.
Thank you so much. Hi everyone, I'm Darsh Agarwal from Team Kaizen. With me, I have Arivir Sethi, also from Team Kaizen. We are a robotics team from Jayshree Periwal International School, Jaipur, and we participate in this competition known as FRC, First World Robotics Championship. I'll hand over to Arivir to explain more about the competition.
Hello everyone. As Darsh already said, we are Team Kaizen who participate in the first robotics competition. The uh, the first robotics competition is the biggest competition in is one of the largest and most competitive high school robotics programs in the world. It is run by the First Foundation, which was founded in 1889 by Dean Kamen. Carmen's goal wasn't just to make robots, it was to change culture. He wanted engineering to feel as exciting and respected as professional sports. The idea was, what if students looked up to engineers the same way they look up to athletes? In its early history, the first official competition was held in 1992. At that time, there were only 28 teams and it was held in a small gym. The robots created were very simple compared to today. They had very basic mechanisms, very limited technology. They weren't very polished, but the core idea was already there. They worked in teams, solved real engineering challenges, and competed under pressure. Over time, the first robotics competition scaled aggressively. More schools joined, sponsors got involved, and the level of engineering shot up exponentially. Today, the first robotics competition has thousands of teams across the world, participation from dozens of countries, regionals and international championships held separately. It is no longer a school activity, but a global engineering league. The, today, the competition looks a lot different. Every year in early January, first releases a new game challenge which no one knows about beforehand. The challenge defines the layout of the field, the rules the game follows, the scoring system, and the tasks the robot must perform. These tasks can include things like picking up and placing objects, shooting balls into targets, climbing structures, and balancing on platforms. Each year is completely different, so teams can't reuse old designs. After the game is announced, the build season starts. This build season is usually 6 to 8 weeks long, where teams go from nothing to making a fully functional robot. In that time, they have to design the robot using CAD, build mechanical systems, wire electronics, program autonomous and driver control modes, and test and iterate their robots. This is an entire engineering cycle being compressed into less than 2 months of time. The robots are serious pieces of machinery. They can weigh up to 50 kilograms. They use motors, gearboxes, sensors, and cameras, and are built using real engineering tools and processes. They involve multiple disciplines like mechanical engineering, electrical engineering, programming, system integration, and more. Most teams use professional tools like CAD software such as Onshape, which is the exact workflow we're going to be showing you guys. First is different because it isn't just about winning. It's about something called gracious professionalism, which basically means you compete others, but while competing hard, but you also help others. Don't be toxic to other teams, and you help them out and help them perform the best they can while also trying to beat them. Teams share their paths and their code and help other robot in the middle of the competition. They collaborate even while competing by like sharing tactics or sharing pieces of useful pieces of information. The we- first also gives a bunch of awards such as design for innovation and the impact you've had in the community. First, teams also have a huge impact on in the real world by completing various outreach activities, spreading the word of STEM, and uh, helping people learn about STEM and start up in engineering. The first robotics competition isn't just about building robots. It's about learning how to think, design, and solve problems like real engineers under pressure in teams and in the real world. Now we'll be talking about our own FRC team Kaizen 1042-8. Over to you, Darsh.
Yes. So
Yes, okay. Sorry to interrupt you, Darsh. Aryaveer, your whatever point you have mentioned was great. But we have one thing here. I think you have already shared your screen, but it is not visible for us. So kindly do one thing, stop sharing and try to share it again so
Oh,
that we
I'm
can
so
also see
sorry.
what you are sharing. Yeah, that is completely fine.
Yeah. Um, how about now?
No, it is still saying click exit to yes.
How about now?
No, if you when you are sharing your full screen, it is not properly visible. So you can exit from full sharing and then that's how you can share.
Mm, mm. All right, can you see it now?
Yes, now I can see it.
All
And I
right,
think for all the viewers, it will be clearly visible, so you can share it like this.
all right.
All right. Yes. So yes, Darsh, you can continue now.
Yes. So about Team Kaizen. So last season we were a rookie team, as in our team was established in the last season, and in our first year we won three Excellence in Engineering awards, and one of the team members last year called Spursh Ranjan, he was nominated for the Dean's List Finalist Award, which is one of the most prestigious awards, individual awards that you can get in the first competition. So now, in this session, we'll be talking about the whole process of building a robot. So we're going to start with the CAD, where we design and we visualize what our robot should look like. Then 3D printing, where we understand how we can actually bring a few the parts that we design physically in our hands, and then we'll move on to the assembly, where we check each part and we assemble them together. And then the main part, which is programming, where we understand how we can bring life to the whole robot. In today's session, we're going to be covering the concepts behind this, of how everything is working. In the next session, we're going to deeply dive into them and teach you how to actually use each software. So I'll hand it over to Arivir Sethi to start with the CAD.
Right, thank you so much, Darsh. Starting off with the CAD, we at Kaizen use a software called Onshape, which is a very useful software because it's all online, like on the browser, and you can share it very easily within your team. And also, Onshape has this feature where you can input lengths of any unit, like feet, inches, meters, centimeters, micrometers. It doesn't really matter. It automatically converts them into the standard length size which you selected earlier. This allows us to create detailed 3D models of each individual component instead of just guessing the sizes, which helps us get a good gauge on what our robot is actually going to look like and helps us decide what changes we might want to make. Another thing that CAD is very useful for is when you want to make any changes once you've actually made your robot. Like if you've already made your robot and you realize that you want to, for example, add another shaft or add another shaft sleeve for extra stability, you can try making those changes to the CAD model of your robot instead of having to actually open the robot. Because if the change you make seems rudimentary after you've made the CAD design, you don't actually have to disassemble the entire robot and reassemble it again. So CAD is just very useful to have something to model the robot for before actually building it. I'll show you guys the setup we use for CAD right after this presentation is done. Right, so for the next part of the thing we're going to show you is 3D printing, which is how we actually make custom parts which we might not have available to us. For example, spacers, which aren't as commonly available in India, where Team Kaizen is, we often like to 3D print those. And anything which we can't necessarily buy or don't necessarily have, we just 3D print that in a software called Cura. We download a CAD model, transform the files from CAD to STL, and then we upload it in a software called Cura, with which we can connect to 3D printers and use those STL files to print a design. These designs can be used in many different things, like as I said, spacers before, or even parts of our intake, or even parts of our shafts. So 3D printed parts are very useful and very versatile for anything we want to use. And also, when you're on Cura, I'll show you guys the user interface for that later. But when you're on Cura, you can select the percentage of infill those 3D printed parts will have. What that basically means is you can select what percentage of the 3D printed part actually will have the filament in it. You could perhaps go with 80%, 50%, 30%. This helps decide the density and the strength of the individual parts. Another thing you can customize is the uh, pattern of the infill. You can have hexagonal patterns, you can have net patterns, you can have tetrahedral patterns. Each pattern has a different use. So, for example, hexagonal patterns gives you more stability, and something like a web pattern gives you like makes the part be able to bend more, contort its shape more, and different use cases require different shapes. Now we'll move on to assembly. Can you go on, Darsh?
Yes. So once all the components are printed and they're ready, we move on to the assembly stage. And this is where we go from like individual parts of a robot to a complete structure. And assembly is not just about putting screws into holes. It's where we test whether our design decisions actually work in real life. So the first thing that we focus on is the alignment, because even a small mishap in the alignment can change the whole motion, the whole balance, or the load distribution of your bot. So instead of rushing, we carefully position each component and ensure that everything sits flush and stable. Then we we, stra- uh, we check how strong the structure actually is. If it decides to flex too much, then that means that the whole design needs reinforcement. Sometimes sometimes it can mean that tightening fasteners properly, or that maybe during the CAD process there must have been some mistake with the alignment. Also, a part that may fit perfectly in the digital model may not actually fit properly in real life. So these sort of variations are what we check when we assemble each individual part together. And by the time the assembly is complete, we're confident that the physical structure is strong, aligned, and ready for the programming integration. So now we'll move on to the programming part, which is where we actually bring life to the whole robot. So for programming, we use a software known as PictoBlocks. And the reason we use PictoBlocks is because it allows us to build logic visually using block-based coding, which makes the structure of the program very clear. So instead of writing long lines of code, we immediately break the system into smaller functions that are more readable and more understandable. So, for example, we start with something simple like how do we move one motor, or how do we read an input of a specific sensor, or what should happen if the sensor detects an object. So, so in essence, we first define the inputs and the outputs. Inputs are things like the sensor readings or button commands, and outputs are the actions like motors rotating, LEDs turning on, or any mechanism activating. And then we connect them using logic. So, for example, if a sensor detects an object, so we might want to make it activate a specific motor, or if a specific set limit is reached, then we want to stop the movement. This is known as conditional logic, where the robot becomes very responsive and doesn't run blindly. It knows what it's doing and ensures that it doesn't execute the wrong command randomly. So when we do block based coding, we test each small block individually before we actually put them together, so that if there's any error in the whole program, we know exactly where that error is occurring from. So we don't have to go through the whole code again. We can just find it out as we're going through it, right? And so we ask whether is the sensor value correct, or is this condition written properly, or is the motor command placed in the right sequence. And this is known as debugging, where instead of randomly guessing where the error would be, we do it step by step. So how I said that we test each block. So we go line. It's like going line by line just to check which line or which block is actually causing the error. And then once each function works independently, we combine them together. And that's when the robot starts to move smoothly, responds correctly, and performs the task as intended. So, but even after combining them, we may have some more errors. So we ensure that we're able to check properly whether by combining two specific blocks, maybe is there some error coming into that, and then we fix that error by doing more debugging, which then allows us to ensure that the robot will run smoothly. So I'm going to move on to showing you the software. Me and Arivi are going to show you all the softwares that we have talked about. And in the next session, we're going to talk about how to actually use them for your bot. So I'll be sharing my screen to show you the PictoBlock software. Then Arivi will move on to the Onshape.
Yes, so Darsh
Right.
and Aravir, till this part, it was great, and I hope that all our viewers are actually having so many thoughts that how they can also build, and they might have received the idea, and now you can also talk about your software part so that it will help them in a much better way. Before that, I would like to know from viewers if you have any question or any doubt, if there is anything you want to ask till now, whatever we have discussed, kindly drop your questions in the chat box. Yes, we can also take your questions and we will surely try to help you out with the questions. We will give all the answers. We have Aryaveer Darsh here with us who can solve your doubts as well. So, viewers, also I have shared the registration link in the chat box. You can check that link as I have mentioned when we started the session that after these webinar you will be receiving your certification, and to get your certification it is very important to have the registration done. So I have shared the link. Kindly do register yourself and you can also ask your doubts. So yes, Aryaveer, now you can take over by sharing your PictoBlocks or the software you wanted to start with.
Right. Just before starting, could any of the viewers let us know if they have any questions about anything we've said so far? Because before we move on to the softwares themselves, it would be easier for them to understand if they ask if if
Yes,
there's anything
yes,
they
for
don't
sure.
understand.
So I am actually looking into the chat box and I will let you know in between if I'll receive any question. Till now, there are no questions and everything is going well and everything is clear. So I am waiting for the question. Yeah, so first question we just received from Sanvi Sharma is making a robot hard. So yeah, from your suggestions, Aravid Dash, what do you think? Because you have participated, you have built your own. So, what comments or what valuable information you can share about it?
Mm, See, Sanvi, building a robot is only hard if you try to do it all at once, if you don't take a structured approach. Building, if you have a structured approach, if you've made a plan of action well in advance, how you're going to design the robot in CAD, what kind of programs you're going to use, what kind of mechanisms are you going to connect with each other, how your robot's actually going to work. If you have the image, if you have it all planned out well in advance, and you've made a plan of action and you execute it along with your teammates, no, I don't think robotics is hard. But if you move without any structure, if you just try to make something in the last few weeks, in the last few days, then yeah, building a robot can be very difficult.
Yes, so I believe for Sanvi, it is now the query is resolved. Wonderful, Aryavir. Yes, I think, yeah, as Aryavir mentioned, it is not that difficult. It just depends on how you are designing it and the time you are actually giving to your robot, right? So the next question that we just received, that won't CAD designing require a powerful computer?
Um, No, CAD designing itself does not require a very powerful computer. But if you are processing that design and using that to print like complex parts with a 3D printer, that can require a strong computer. But I doubt that even in our first robotics competition, we don't need to print parts of that high of a complexity. So any laptop with let's say Windows 10 would be able to handle any sort of CAD designing which you guys will need to do. So I don't think that the processing speed of the laptop will affect your CAD capabilities too much.
Yes, so these were the questions we have received till now, viewers. So yeah, the rest is saying that everything is fine. We can go ahead. So Meanwhile, if I'll get any question, I will hand over the question to you. Okay. So yeah, we can start with the software part.
Right, of course. Okay, I'll just show you guys the CAD software we use called OnShape. Is my screen visible to everyone?
Yes, Aryavir, it is visible.
All right. So once you log into OnShape, it should look something like this. Here here you'll have all of your previous projects. You'll have your profile here, your notifications and everything here. What you would want to do to make a new project is go to create, go to document and name it anything. For the sake of this class, I'll just name it Codeavour bot. And it should open in a minute. Yeah, there. And this is the basic interface of the OnShape CAD you have. It is much easier to use if you have a mouse. I'm on a Mac right now, so I can't scroll that easily. You can zoom in, you can zoom out. Above, you have all the tools. I'll be showing some of these tools to you in tomorrow's session in detail and how to use them. You can make sketches. Uh, you have to select planes for which sketch you want to make. And yeah, that's pretty much the basics. That's pretty much the user interface of OnShape, the software which we're going to be showing you guys tomorrow. I'll show you guys more details about what shapes you can make, what uh, 3D designs you can make, and how you can convert the CAD files into STR files and go to the 3D printer using Cura in tomorrow's session. Now, over to you, Darsh. Can you show us the PictoBlock software?
Yes. I'm just going to share my screen. Is my screen visible? I hope my screen is visible to everyone. As you can see, a lot of you would be really familiar with this, as this is practically based on Scratch, right? Even the whole layout, the whole UI is completely Scratch. And so how this works is we have multiple blocks, right? That uh, when we put onto the editor, we can demand a specific task or create a specific function. I will be going deep down into this in tomorrow's session on how each block works. And some of you may be asking, what's the difference between PictoBlocks and Scratch at that point? So the difference between that is that PictoBlocks allows connectivity with your bot directly. So in Scratch, you can't connect to an Arduino board, you can't connect to a Quirky bot. This allows you to do that, right? So that you can directly run the code on your bot and you can test it out. That's that's practically the only difference between Scratch and PictoBlocks. And so this allows you to have a greater understanding of how everything's working, right? And since this is just a sample file, right, we have something known as a sprite, right, whose name is Toby right now. And so in this, let's say, for anyone who knows the basics of Scratch, you'd know that if I put this yellow block of when the flag is clicked, and then I put a blue block of move 10 steps. So that means that Toby, my friend over here, is gonna move 10 steps as soon as I hit the green flag, right? But obviously, when we code the robot, we're gonna go much deeper, much on how to connect, how to wire each motor, how to get it running. So this was the CAD software. Um, Arvi, I hope you like to show the 3D printing software so that everyone can understand how you convert the CAD to the actual product.
Right. Before continuing on with any more of the softwares, I seen that a lot of you are questioning about whether these softwares are free, especially on Shape. And I like to mention that all of these softwares are 100% free of charge. You all can access them for free by just making an account on Google. So I hope that answers you guys' questions. Now, moving on to 3D printing, we like to use this software called Cura. I won't be able to show you exactly how it works, but I'll show you a rough overview of the user interface. Just a second. Um, uh, yeah, here. So this is how Cura is gonna look once you opened it. You, it's gonna ask you to add a printer, which you can connect any local printer off of Wi-Fi or Bluetooth or cable, depending on what 3D printer you have. So you just go here. There is actually no 3D printer in my vicinity right now, so I can't show you. But once you find the 3D printer, you just click on it, and then you have to click on next, and there's a few extra steps after which you can uh, access the 3D printer. Then it gives you an option to insert STR files, which you can just drag and drop the STR files or just find them on your computer by going to the upload section. And after you've selected the STR files, it'll ask you a bunch of questions like how much filament do you want to use for this? What's the infill? What's going to be the infill pattern and everything? So you can just do all those customizations. And in tomorrow's class, I'm going to tell you guys what each different infill pattern means, what each different infill percentage is going to lead to, and I'll show you guys some 3D printing done with this Cura software. Now, does anyone have any questions about the 3D printing or the picto blocks?
Till now, we don't have any with the with this software. If there will be any question, I'll forward it to you. And viewers,
All
I
right.
believe till now everything is clear. And whatever questions are there, you can put. I will reply. And also, Aryaveer and Dash is there to reply your questions. Yes, Aryaveer.
All right. So before we wrap up today's session with you guys, I wanted to tell you guys about robotics competitions in general, like what what you guys should be doing, how they work in general, how you should be prepared for them, and how you should allocate your time toward them. So, robotics competitions are structured events where teams design, build, and program robots to complete specific tasks under a defined set of rules. These competitions are used in education and industry to simulate real engineering processes in a controlled environment. Most robotics competitions follow a similar format. At the start, the teams are given a challenge or game. This includes a defined objective, a set of rules, a playing field, or environment. The challenge changes every year or every season. Like, I think some robotics competitions have different season in every 4 months. Teams are then given a fixed amount of time to develop a solution. This is often called the build or development phase. And in this time, the teams have to analyze the problem, they have to design a solution, they have to prototype their robots, they have to construct their robots, they have to program the how the different mechanisms in their robots are going to work, and then they'll have to test their robot under actual game conditions. Most robotics competitions often have a size and weight limit, with some robotics competitions also having a budget limit and restrictions on what materials or components they can use. These constraints are intentional because they reflect real world engineering conditions. Like, you won't have a, a lot of resources to build something simple like a drill or something. Robotics, robots in competitions are typically made up of several integrated systems. The mechanical system provides structure and movement. The electrical system includes motors, wiring, and power sources. The control system consists of programming and logic that determines how the robot behaves. The performance of the robots depends on how well these systems are integrated and how well they can interact with each other. During the actual competitions, robots are tested in matches or runs. In many competitions, matches are divided into phases such as autonomous phases, manual phases, or the end phase. Each phase is different for each robotics competition there is. Scoring is based on how effectively the robot completes tasks within each of these phases. Another important aspect of robotics competitions are judging criteria. Competitions often evaluate more than just robot performance. Additional criteria may include design quality, innovation, efficiency, team documentation, and how well the team works together and the communication they have within themselves. This reflects the fact that engineering is not only about the results, but also about the process and reasoning you have to get to them. Robotics competitions also require team organization. Teams are usually divided into roles such as design captains, programming captains, electronics captains, and strategy and testing captains, with a lot of team members under them. Effective coordination between each member is necessary for the robot to function correctly. One of the most important concepts in robotics competitions iteration. Initial designs rarely work perfectly. Teams must test, identify issues, and refine their designs many different times. This iterative process is a core part of engineering practice. Finally, robotics competitions serve as practical introduction to real-world engineering. They simulate working under tight deadlines, managing very limited resources, and solving open-ended problems. It, they also make you integrate multiple different technical systems together to reach a solution. These experiences are directly relevant to fields such as mechanical engineering, software development, and product design. Most of these facts hold true for all robotics competition, including Codeavour 7.0. And many of the things we've told you integrate to large robots such as the ones used in FRC, smaller robots such as used in FTC, and even uh, very small robots such as the ones used in the first Lego League. And I believe they apply very well to your Codeavour 7.0 competition as well. And I strongly believe that if you follow these robotics competition and engineering principles we've shared with you, you will be able to achieve very good results in your Codeavour competition. Now, if anyone has any questions, please don't be afraid to write them in the chat box. We will respond to them promptly.
Yes, so Darsh, Aryaveer, this was really amazing. I believe that all our viewers have got so many ideas and they at this session, this webinar, whatever information or thoughts that you have shared here today, it is really going to help them all. And if there are, right now, I'm not able to see any questions. They are clear with the questions, and whatever the questions we had, we have already taken up those. Okay, so I am also looking into the chat box. If there is any questions, meanwhile, we can confirm those questions. Yes, so thank you so much, Darsh, Aryavi, for such a valuable insight, for sharing such valuable insights with us. And I'm pretty sure that our participants found today's session helpful and gained a clear understanding of 3D printing, what and how we can use the software and the software we need to use, and this will help all of us to participate in Codeavour 7.0, and they can also use this idea to build the robot. And next, because tomorrow, like tomorrow again, we are going to have one session, and there we are going to discuss other parts as well, and I believe after that everything will be clear. Okay, so there is one question coming. Is there any AI involved in these programs?
So
Um,
it
sorry, Darsh, go on.
Yeah, so in terms of AI, really it's mainly as we all know, AI is really prevalent in terms of coding, right? Like the line-based coding that we do, right? And in for PictoBlocks, not really, but yes, AI does really help with when it comes to the ideas of how you might want to lay out your robot. It can't make the whole CAD, it can't make the whole program, but it will definitely be a good assistant to make sure uh, that you can save time in debugging errors when AI can directly tell you what the problem is, right? It just saves time and gives you more time for testing and for practice.
Okay, thank you so much, Dash, for solving this query. Now I believe this is resolved now. Okay, So viewers, thank you so much for being such an enthusiastic audience, and we encourage you to start applying these concepts in your project and take your robot design to the next level. So tomorrow, as I mentioned, we will be having another session. So we are going to wait for you all again with us to join in our another live webinar so that we can discuss more things about it. And once again, I thank you, Darsh and Aryaveer, for sharing their thoughts with us. So viewers, I have already shared the registration link. I hope that you all have registered now. And if anyone is there who is not who haven't registered themselves yet, kindly open the link and register. So thank you so much, everyone. Have a great day ahead, and we look forward to seeing your amazing innovation in Codeavour 7.0. Thank you so much.